My conic sections project is based around orbits and their relation to conics. The Archimedes death ray is a parabolic mirror design and it's designed to focus the light from the sun onto a single point, which heats up that point due to the sun's energy being focused on that one point. Now, the focus is a major part of an ellipse as it relates to many things that happen in nature. For example, orbits are based around their ellipses and their foci. Now, this is a Mythbusters clip from when they built the Archimedes death ray, which showcases the focus. Now, the mirrors are angled more towards the outside to create a parabola, focusing the light onto a smaller point, heating it up faster. Now, in this picture, the black dot right here represents the Earth, and the yellow dot represents the Sun. And from what I remember in physics, Kepler's first law of planetary motion says that the orbit of planets are ellipses, and the sun is the focus of the ellipse, or whatever body the object is orbiting. Now, these orbits can actually be any kind of conic section, but looping orbits are always ellipses. Now, to put this into better perspective, I guess, think of the pencil as the object that is orbiting, in this case Earth. Now, the string is gravity, and one of the focal points is the sun, or the body that the object is orbiting. Now, as you move away from the center towards the outside, and the string is taut, which is basically representing gravity, then as you try to move it away and around, the string or the pencil will draw an ellipse. And as one side of the string grows longer, the other side has to grow shorter because there is a set amount of string. Now, this is a, I guess, mathematical representation of that. Now, in this representation, the total length is 10. Now, as it moves around the ellipse, the blue line is lengthening and shortening, while the red line is also lengthening and shortening. But no matter what, the lengths are still going to equal 10, no matter where they are. No matter how far away they are from the focal points. Now, back to space. When Earth's orbiting the sun, and due to its eccentric nature of its orbit, the closer or farther away it is, depending on the time of the year, then the longer the days are or nights are, depending on where it is. Now, if you're in the northern hemisphere and you are in the summer, then it's going to be longer and cooler summers due to the Earth being farther away from the sun, which is represented by this Earth going by. Now, due to the tilt of the Earth's axis, the winters in the northern hemisphere are shorter and warmer than that of the southern hemisphere, and vice versa. And the winter and summer solstice are at the vertices of the ellipse from the Earth's orbit, due to it being the shortest and farthest distance from the sun. Now, since the Earth arrives at either vertice at some point in the year, you can see that one vertice is closer than the other, producing the winter and summer solstices, which are the shortest and longest days and nights of the year, respectively. Alright. Another example of an elliptical orbit is the moon orbiting the Earth. As you can see, the focus is the Earth, and the perigee and apogee are the vertices of the ellipse, the perigee being the closest point to the Earth and apogee being the longest distance from the Earth. And to give a more visual representation, here's a clip from the game Kerbal Space Program, which is a rocket and space simulator. Now you can see as the engines are fired and the orbital velocities increase, the perigee increases until it gets out of the Earth's atmosphere. You can see by the blue line representing the ellipse of the orbit. And as it gets out of Earth's atmosphere, it goes into a looping orbit, which makes it to where it will keep going until something other than gravity affects it. And after the orbit passes the circle, which you just saw right there, the apogee becomes the perigee, and it just keeps increasing, which are the vertices of the ellipse. And that's my presentation on conic sections and how they relate to space and orbits.